Let's look at some examples of some quantitative variables, and let's think about whether each variable is discrete or continuous. Remember, a quantitative variable can be either discrete or continuous. Let's start with number of siblings. Then number of TVs owned. The number of TVs that people own. Maybe account balance, the amount of money people have in the bank. Or maybe we could do shoe size first and then account balance. Then maybe commute distance, the distance that a person has to travel to get to work or to school. Then maybe temperature, height, and maybe amount of time spent on homework per week. Now it's a discrete quantitative variable if there's gaps in which you can't have any possible values. And it's a continuous quantitative variable if there are no gaps and a value can be anywhere on the number line. And let's think about this for every example. Let's start with number of siblings. A person can have 0 siblings. A person can have 1 sibling. A person can have 2 siblings or 3 siblings. So the number of siblings a person has can be a whole number, but it can't be anywhere in here. For example, a person can't have 0.5 or 0.6 siblings, and a person's number of siblings also can't be in here. It can't be 1.1 or 1.2. So we can already see that we have 2 gaps in the number line, which we can't have any possible values. So the areas that I'm marking in red are where there can never be any values. But we can have values here. A person can have 0 siblings. A person can have 1 sibling or 2 or 3 siblings. So I'm going to mark off the areas where we can have values in green. So wherever we have a green place on the number line is where we have a place where a person's value can fall on the number line. And we can see that number of siblings is discrete because we do have these red areas that are gaps in the number line in which there will never be any values. There will never be any values in any of these red areas. Number of TVs works the same way. I could just copy and paste this for number of TVs. A person can have 0, 1, 2, or 3, or 4 TVs. So a person can have a value here. A person can have 0 TVs. A person can have a value here because a person can have 1 TV. A person's data value can fall at any of these green areas. The number of TVs a person owns could be 0, 1, 2, 3, 4, or even 5 or 6, but it can't be anywhere in between 0 and 1, or between 1 and 2. It can't be between two whole numbers. So number of TVs is also discrete because we have these red gap areas where a person will never fall on the number line. What about shoe size? Well, shoe size can be, a person's shoe size might be 10. It could even be lower than 10, but let's just start at 10. It could be 10.5. It could be 11, or 11.5, or 12. So it can be either a whole number or a number with a 0.5 at the end. But it can never be anything in between any of these numbers. I've never heard of a person who could have a shoe size of 10.7 or 10.8. So you can't have any values in here. Like I said, a shoe size can't be 10.7, 10.8, or 10.9. You also can't have a shoe size in between here. For example, it can't be 10.2 or 10.3. So this is also a red gap area. And let's mark off the possible values. One way to think about this is, if it's possible to mark off the possible values, and the possible values are always separated like this with red gaps in between, then it's discrete. What about account balance? We could maybe start at, let's start at 0. That's the lowest a person's account balance could be unless they have a negative account balance. Then after that, let's go up to 0.01, which is 1 cent. That's the next highest number that a person's account balance could be. A person's account balance could be 2 cents, or 3 cents, and the possible values would just keep going up. It would be 0.4, 0.5, 0.6, and so on. So these are the possible values that a person could have for their account balance. And it's not possible to have anything in between. For example, a person's account balance couldn't be right here at 0.013 or a person's account balance couldn't be right here at 0.007 or 0.008. And a person's account balance couldn't be right here at 0.013 or 0.014. And the numbers in between 2 cents and 3 cents would be numbers like 0.024 or 0.025. Those also aren't possible. So we can't have anything in any of these areas. So it is a discrete variable. We have these possible values that are separated from each other, and between each of these pairs of possible values, there's this red gap area in between. There's a red gap area between 1 cent and 2 cents. There's a red gap area between 2 cents and 3 cents. And we would keep having more of these gap areas if we kept going up higher. So actually anything that has to do with dollar amounts is usually discrete because you can't have anything between these values. You can't have anything between these two values here or between these two values here. So what about, what's the next one? Commute distance. Maybe commute distance in miles or commute distance in feet. It actually doesn't matter whether we say it's miles or feet. So let's just call it commute distance. Well, I guess miles would make more sense. So 0 miles, 1, 2, 3, 4. Now what if a person asked us to mark off the possible commute distances that a person could have, and to mark them off in green, and the person also told us to mark off the areas where you can't have any commute distances. Sorry, I didn't say that right. What if a person told us to mark off the possible commute distances in green, and that person also told us to mark off the areas where you can't have the commute distance in red? So the person tells us to mark off the gap areas in red. Sorry. Let's move on to commute distance. Imagine a person asked us to mark off the possible values of commute distance. A person asked us to mark off the possible values of commute distance in green, and to mark off the gap areas in red. Well, it's not really clear where the gap areas would be because, well, if we made the number line like this wouldn't be correct because a person can have a commute distance between 0 and 1, or between 1 and 2. For example, a person could have a commute distance of 0.45 or 0.5 or 0.6. A person could have a commute distance of 1.1 or 1.2.